When retrieving a web page, a browser typically has to download the main HTML page, as well as a number of other resources: images, sound files, CSS, JavaScript files, and other things. Many of these resources are shared among web pages in a site and sometimes across web sites, so that modern browsers cache locally many of these resources. Retrieving a local file from the cache is always faster than downloading it again from the network, no matter how small the file may be. Now, the way it works is pretty simple. Anytime you load a new page in the browser, it checks to see if any of the associated files are already available locally. If this is the first time you visited the page, that will mean everything, except maybe for some files that are shared across web pages or sites. If this is a repeat visit, the page is likely to load much faster, given constant network speed, because some or all of the resources will be available locally, unless, of course, they've expired or you've cleaned up the cache. You can control this process to some extent by setting various HTTP headers as part of a response to a request for web pages and resources. You can do this through three basic mechanisms: freshness, validation, and invalidation. This is all part of HTTP and controlled through HTTP headers. So freshness allows a response to be used without rechecking it on the origin server, and can be controlled by both the server and the client. The expires response header sets the date when the document becomes stale. And then cache control, using the max age parameter, tells the browser how many seconds the response will remain fresh. And then validation is how you check to see if a cached response is still good after it becomes stale. So, for example, if a response has a last modified header, a cache can make a conditional request using an if modified since header to see if the content has changed. This is a fairly weak form of validation, and a better option is with entity tag mechanisms, or ETAG mechanisms, which essentially sets a version number for a document. And then invalidation is usually a side effect of another cache request. For example, if a URL associated with a cached response later gets a post, put, or delete request, the cached response will be invalidated. In theory, the browser cache is a nice feature to make the web appear faster to the user by loading pages faster when resources are already cached locally. But over the years, there have been bugs, security concerns, and less than fine-grained control over what gets cached that have made it a challenge to use this feature effectively. But it's still a viable option. Here's a browser cache action method. And all I'm really doing in this code is using some of the features built into ASP.NET that are exposed by MVC in order to set some of the browser cache options. So one option is to use the Set Cacheability option, and in this case use the server and private option. And there's public and private and all those options that I talked about earlier. I can set the max age to a time span of 30 minutes from now. And I can also set expires to expire at a specific time. In this case, it'll be 2:45 p.m. today. And then can also set some validation headers, so set the last modified as 2 hours ago. And then can also use an ETAG in order to essentially give a version ID number. And this is just any kind of custom value that you want to use. All right, and look at the browser cache view here. And there you can see that all it has is static text. All right, so I'll go ahead and run this and click on the browser cache. So now what I'm going to do is I'm going to press F12 to open up Internet Explorer's Developer Tools. And all of the major browsers have equivalent tools here. So nothing really special about Internet Explorer. Oh, but if you do use Firefox, you'll want to install Firebug, which really adds a lot of additional debugging features within the browser. Okay, so I'm going to start capturing and refresh the page. And that lets me look at all of the items that were requested for this page. And I can double click on the request for the page itself. So this is the original URL that the browser navigated to. Double click on that. And here I can see the request headers. And so you can see that these are just the standard request headers. And then look at the response headers. And you can see that because of the properties that I set for the response within the home controller, within the action method, I have an E tag set to that value that I set there. I have an expiration date, and I have a last modified date. And as you can see, there's a difference amount of time between those two values. Okay, so you can set parameters for the browser cache and hook into what it's doing. And this has some use within modern browsers. But what's coming and what's really here now is that with HTML5, there are much better ways to do this. Historically, web servers have been able to store client-side data in the browser cache as well as using cookies. These techniques have caused problems over the years, including some security issues. But in HTML5, web applications now have some better options for client-side storage, including some caching features. The intent is to let web applications store session state and other application-related data in the browser, even to the point of allowing offline applications to execute, while severely limiting the ability of malicious applications from damaging user computers through either excessive storage or malware. So, web applications could store user preferences or even complete state so that users can start back up where they left off the last time they visited the site. Client-side data in HTML5 is segregated by site, really by origin. So pages from one site can't read the data of another site. But multiple pages from the same site can share data and use it as a coupling mechanism. The application can choose the lifetime of the data, storing it temporarily just for the current session, or save it to disk and essentially making it stored permanently. In this part of the course, I'm going to explore one of these client-side storage options, web storage, which uses the local storage and session storage objects. But first, a word about security and privacy. None of the HTML5 client-side storage options include encryption. Anything saved in memory or disk is there in clear text form. It's very important that you understand that. So any users who are curious can examine the data, and in fact, most browsers' developer tools make it very easy to explore. And this means that the data is available and visible to other users who have access to the computer, as well as any malware that's installed. So as a web developer, you should never store any sensitive data using these storage techniques. Things like passwords, financial information that the users typed into a form, or credit card or account numbers. Douglas Crockford, who's Yahoo's JavaScript guru, puts it this way, quote, "This is sensitive information that people keep hidden in their wallets. If you save this information using client-side persistence, it's almost as if you wrote the credit card number on a sticky note and stuck it to the user's keyboard." End quote. So you're not exactly broadcasting across the internet, but it's more exposed than before, and probably more so than a typical user would like. And then one other word of caution. Browsers are implementing HTML5 features more and more every day, but few have a full implementation, even of the draft specifications. Be sure to use any of the various techniques to bypass the functionality for browsers that don't yet support these features. Thankfully, over time, this will become less of a problem as the major browsers fully implement HTML5. All right, so let's talk about specifically HTML5 web storage. This is based on the web storage draft HTML5 specification. But don't be put off by the draft in the name. Modern browsers are implementing web storage to varying degrees. Okay, so what this does is it implements a storage object with properties in the JavaScript window object. So it's actually essentially enhancing the DOM that's available to your JavaScript code. And the storage object is a persistent associative array that maps string keys to string values. So it's a fairly typical JavaScript kind of an object. Browsers that implement web storage provide two properties on the window object: local storage and session storage. The difference between the two has to do with the lifetime and scope of the data that you store in each. But otherwise, the mechanics of using the two properties and their underlying objects are identical. You can store native data types as well as structured data such as objects and arrays. Okay, so the first is local storage. Data stored here is permanent. There's no expiration date associated with it, and so it stays stored on the user's machine until the web application deletes it, or the user does so using a tool within the browser. The scope of data in local storage is the origin URL, as defined by the protocol, hostname, and port. That's important, those three elements: protocol, hostname, and port. This is based on the same origin policy that provides a security constraint on JavaScript code. For example, here's a sample URL that defines one origin. And then this URL has a different origin because it has a different port number. And then this one differs because it has a different host name, which is a different subdomain in this case. And then this one differs because it uses a different protocol, HTTPS instead of HTTP. Okay, so all four of these are different document origins. So they're going to have different local storage. So only data used by documents from the same origin is going to share local storage data, no matter where the client-side script originated. And to be clear, all documents from the same origin can read, write, and overwrite the same local storage data. Documents from different origins can never read or write each other's data. Local storage data stored by different browsers also has a different scope. So if you visit a site with the same origin using Opera that stores data, then visit the site using Firefox, Firefox isn't going to have access to Opera's data. So in fact, as a developer, that's part of the reason why I have so many different browsers installed on my development machine, because I'm needing to test these interrelationships or the segregation of data between the different browsers. All right, so that's local storage. And then there's session storage. Session storage has a different lifetime than local storage. Instead of being stored permanently, session storage has the same life as the top-level window or browser tab in which the script that created it is running. Once you close the window or tab, the data is history. But the lifetime of session storage is complicated a bit by a browser convenience feature. Some browsers let you reopen recently closed tabs and restore their browsing sessions, including in case of a browser crash. So session storage may survive past your closing the tab, and the particulars are going to vary by browser. And it may also be available in a browser's developer tools, as I'll show you shortly. The scope of session storage is the same as for local storage, except that session storage is also scoped by the window containing the document that created it. When that window or tab is closed, any session storage data is deleted. But if you have two windows open with documents from the same origin, the two windows have different session storage data. In that case, neither window can read or write the data in the other window's session storage. And then this Windows-based scope only applies to top-level windows. If you have a window with two iframe elements, each of which holds a document from the same origin, the two frame documents will have the same session storage. So this all may seem a bit convoluted, but in practice, you'll usually just be working with a single document in a single window or a tab. In that case, the rules are pretty simple and straightforward. here's the caching solution and the web storage action method that opens up the view that uses web storage. And as you can see, nothing interesting at all is going on here within the controller. All it's doing is presenting the view. I'm talking here about web storage, which is a client-side browser caching option. So everything interesting is going on within the page. I'll take a look at the view in just a moment, but let me run the application to show you what it does. And in this case, I'm going to use Chrome for this demo because it has the easiest way of viewing web storage. All right, so I'll go ahead and start it. Fires up Chrome, and here's the page. So as you can see, it has a simple form prompting me for potentially some sensitive kinds of information. So I'll go ahead and type this in. Let's pretend that I'm 31, and I'll type in a credit card number. Doesn't really matter what I type in here. There's no validation going on whatsoever. And I'll go ahead and save the info. Okay, personal information is stored, and we pwn you. So the site now has some personal information of mine. If I refresh the site or the page, the data persists. Okay, so I'll close the browser and stop the app and run it again. So simulating that I've gone to lunch and coming back to the page with a new browser window instance. And so notice that when I load the page, I have my name and age. Those were persisted because those were stored to local storage. But I didn't get the credit card number because that was saved to session storage, as you'll see when we take a look at the code. So that number, the previous number that I put in there, is now history. So I'll go ahead and put in another one. And save it one more time. Okay, so now I'm going to press F12 to open up the Chrome Developer Tools. And I'll look at Resources. And notice that I have a local storage and session storage items listed here. So I can look at local storage for this URL. Notice that is, in fact, the URL that I've been at. Select that. And there we have personal information, age and full name. So a user can look at this information within their browser. And then here's session storage for that site. And there's my credit card number. Okay, so at this point I can consider my identity stolen. All right, so now what I'm going to do is copy that URL, and I'm going to go to Firefox. Paste that in, and notice that I don't have the information. So here I'm going to enter different information. And save that information. And I'll go back to Chrome and refresh the page, and notice that I have my information. So that's the information that persists. Because Chrome's web storage is different than Firefox's web storage. And I'll press F12 to open up the developer tools, and come down here and type in local storage. As you can see, I'm prompted with a form of IntelliSense. I can hit Tab and Enter, and there you have that we have two items in local storage. Age is 30, full name is Carol Kleckner. And we can also look at session storage and see Carol's credit card number. So it's a little bit less convenient within Firefox, and Internet Explorer's developer tools operate fairly similar to Firefox. So that's why I originally used Chrome, because it's just a little bit easier. It has that nice GUI interface into looking at local storage and session storage here. Okay, then another thing I can do is I can clear the credit card. As you can see, that clears out session storage. And in fact, I can clear out all of the web storage. And now there's no local storage and no session storage. Okay. So that's how the app works. Let me close my browsers. And let's take a look at the code. So again, the action method has nothing interesting. So let's go look at the web storage view. shut that down. Okay. Okay, a little bit more complex page. I have embedded JavaScript, and I'm using jQuery. But you can put this in a separate file as well. Keep your HTML file cleaner. But in this case, I just put it all on the page, a little bit easier to explore. Okay, so a typical view. I have some style, setting up some local styles. I'm using jQuery, using the 1.8.2, a little bit older version, but it's what comes with the version of Visual Studio and MVC that I'm using. And so here's a ready function. So this code is going to execute when the page is ready, all the DOM elements have been loaded. And so what I'm doing here is, this is the code that restores the values if they're available within local storage and session storage. So in this case, I'm using that local storage object. This is a property of the storage object that is enabled within JavaScript, actually within the DOM that's available within JavaScript, when I'm using a browser that supports web storage. And so it's going to read the value, full name, and use the val property of this val name or this full name control. So this is jQuery stuff here. Actually, val is too. Just very efficient code for finding an element on a page and then setting a value of it. Okay, so that's going to set the full name, originally to Don Kiley or Carol Kleckner. Do the same thing for age, same thing for credit card, except that the credit card is stored in session storage. So it reads it from that location. And then to make it easier for the user, I use the focus method to put the cursor within the full name control. Okay, before we go any further, let's look at the HTML. Very simple, straightforward. Please enter your information. It's all in the shape of a table. So I have the full name, input field here, input fields for the credit card number. Really nothing here that indicates that I'm going to be using web storage for this data. And then I have various buttons at the bottom that save the data, clear the credit card, and clear it all. Okay, so let's go back up to the code. So this is defining the click event procedure of the save button. So I'm defining an anonymous function, and I'm grabbing the value of full name. So here I use the val method in order to get the value of that full name text box and saving it to a variable, JavaScript variable called full name. Do the same for age, and do the same for credit card. So now these variables have the values that the user typed into those text boxes. And here's where I'm saving the information to web storage. So I'm using the local storage object, defining a value called full name, and assigning the value that I saved right here, and doing the same for age, and then using session storage to save credit card. So it's very important to understand the difference, that the reason why the name and age were persisted through refreshes and even restarting the application is because I used local storage. The reason the credit card was blank when I refreshed is that it was session storage. When I restarted the browser is because I stored it in session storage. And then I output the message, your personal information stored, we pwn you. So that's the message that was in red that was displayed at the bottom of the page. Okay, to clear the credit card, nothing fancy. I just used the remove item method of that session storage object and specify which one I want to remove. And then I also clean up the user interface by blanking that out. That doesn't happen automatically. There's no binding between the two here. And then putting out a message saying, we as potential attackers are sorry, but your credit card is again safe. And then similar sort of thing here. So in order to clear everything, I'm using the clear method of local storage, the clear method of session storage, and then clearing out all of the text boxes. And what's nice here is that I don't need to do that for the individual controls, because I can use a jQuery selector here that's going to select all of the text input elements on the page and sets their value to an empty string. So yet another of many reasons to use jQuery if you're going to write a lot of JavaScript within your browser. And then printing out another message. So again, it's client-side storage. I have to work with it on the client. Nothing gets sent back to the server unless I explicitly do something, like a submit button that causes a post back to the server. There's also a storage API that provides a method-based way of working with the storage object that's behind the local and session storage. Usually it's easiest to treat local storage and session storage as regular JavaScript objects. But there are methods like getItem, setItem. I showed you removedItem and clear. So those are methods that you can use, or you can use this array notation within JavaScript for most of those kinds of functions. So you can use the objects however you like, and even mix and match techniques. There are even storage events that are raised when data changes, and you can hook into those events from documents from the same origin. What's funky about the events is that, according to the specification, the events fire in every window with a document open from the same origin, except the one where the data changed that caused the event. So that's how the specification is written. But some browsers incorrectly fire the event in every window, including the one that fired the event in the first place. So just if you start working with those events, be aware of that kind of anomaly between browsers. Hopefully that'll get smoothed out over time.